Hello, today we are continue talking about Datomic pagination implementations, and today I'll show you the second way, which is more usable and more convenient, especially in comparison with previous one. From some recent Datomic version update, it allows us to have so-called query sequence request and returns not just immediately placed in random access memory the result of query, but to create a lazy sequence which we can reduce and fold to calculate some intermediate points or some values. So not all the query result will export it inside memory. So it's quite usable, and we can use this approach to implement an effective pagination. The idea based on that fact that we can fold it in a smart way. For example, let's imagine if you have 100,000 rows and you have to sort them and take first 50 elements. It will work, but it's not so effective approach because first of all we have to sort all the big sequence and then take only first 50 elements of them. For example, if you need to find out the minimal element of big sequence, you do not even to place it in random access memory. You can sequentially go the element, and if it less than current minimum, substitute the current minimum, and if it's greater, then drop it. To find out the minimal element of collection, you have to O by N of time complexity of algorithm and O by 1 of memory, instead of O at N logarithm N for sorting by time and O by N in memory to have all the collection placed. But let's expand this idea on searching not only the one minimal element, but some amount of minimal elements. And that's why I try to implement it efficient implementation of so-called take first sorted by function. It takes the value of how much first minimum values should we get from the collection, and it under the carpet it utilizes JavaUtil tree map and JavaUtil array list and so on and so forth. It doesn't matter, it's technical details. But the main thing, it utilizes the algorithm that you can have a big, long, lazy collection, and you can efficiently reduce and fold it, and your accumulator will hold every time only n values of desired results. And that's why we can combine lazy queries to the Datomic database, and that's efficient implementation of take and sorted by function to create an efficient pagination stuff. So let's first check this function and compare it with naive implementation of sort by and take n, sequential applying different functions, and then compare it to our efficient implementation. Let me call this function on 100,000 elements and sort them by some criteria. I'll start it. Yeah, as you see, the results are equal, so A and B is true, but naive implementation taken from sort by takes about 700 milliseconds, but efficient implementation takes about 45 milliseconds. And also, of course, much less memory. Actually, the amount of memory depends on only n, not on count of all initial collection. And then we can use it for making efficient pagination. And here we can do the same query as in previous snail. give me 10 next customers from name 33, and it takes 28 milliseconds and give all the results. So it's way faster than previous initial implementation of sequential queries, which takes about 1/2 of a second for such type of query. Here we have 28 milliseconds, and it's quite usable solution. It allows first to have a fresh Datomic version for making lazy queries. And second, you have to have efficient implementation of such function and take and first sorted by. So that's it for today, and see you on the next last nail, where I show you the final algorithm which we push to production. See you.